new topic is the thread. This is the concept about the threads that we'll read. You might have done some works on the thread in Java language. So how this threads has a role in operating system, that we're going to read over here. We have finished discussing that about the IPC inter-process communication in the previous class. So thread is also an important chapter over here. What is actually a thread is, if you mark while working in MS Word in particular, when you go on typing in MS Word and you have some grammatical error or some typo error is there, it gives you, you mark that is a small red mark or a green mark, that or it will be on the text will be underlined with red or green marks. This is because when a particular process like MS Word is running, MS Word is a process. So MS Word is running as a process. Now, while the process is running, there might be a small sequence of executions are also running in parallel, right? Those are for checking the grammar or for typo error or for auto saving. So small light processes also works while a particular process is executing. Those are called the threads. Those are called the threads. If you see that when you go for web browsing, you type a particular web address in the URL, you'll find that a text will come one first, then a picture, maybe a picture will downloading, after some time another picture, a half of the picture may be downloading. So it is actually that not the entire process is being working over here. For downloading each of these, there might be multiple number of threads are working over here. So we'll be discussing over here what is actually that those lightweight processes and why it is called lightweight processes. A thread of execution is the smallest sequence of programmed instruction that can be managed independently by the scheduler. What it says, this is being managed by the scheduler. Scheduler will schedule that when the thread has to be created and it has to be destroyed. So the thread of execution is the smallest sequence of programmed instructions that can be managed independently. So the processes can be divided into some threads. In a process, multiple threads may work. In most cases, thread is a component of a process. So that means if you are working with a thread, that thread must belongs to some process. But here we say the thread as a lightweight process. It is called lightweight process, which is basic unit of CPU utilization. Why it is called lightweight process? Because it doesn't take the amount of information that are being kept in the process itself. Process requires all information has to be kept about a process. But thread doesn't keep all the information. What a thread has? Thread has only the thread ID, a identification number. Every thread has a unique ID. A thread consists of thread ID, program counter, register set, and stack. Are you getting me? Only these four: thread ID, program counter, register set, and stack. But if you look into a process, the process keeps many informations. The process keeps many informations over there: resources, other resources, parent, child, many things. It doesn't keep all those. It keeps only these. As it is a part of this process, it can avail all the resources which is being allocated to the process. So no separate resource allocation will be done to these threads. Try to understand. We will create a process. Process may have a number of threads. All these threads will share the code, share the data, share the resources of the process. But they do have different thread ID, program counter, register set, and stack. So it shares with other threads belonging to the same process. What it said shares the code section, data section, other resources, open files and signals. So these are being what? These are being shared over there. So these are being shared. Which are being shared? The code section, data section, resources, open files and signals. These are being shared. And what is not shared? Not shared is thread ID, program counter, register, set and stack. Is it understood? So processes are independent execution units. Independent execution, which are the processes? The processes are independent execution units that contains their own state informations and interact with each other via IPC. So processes interact with each other via what? Inter-process communication. We have read about those things. So processes interact with each other by message passing or by inter-process communication. But thread is a coding construct only. A single process might contain multiple threads. A single process may have multiple threads. All threads within a process share same state, same memory space and communicate with each other directly. So here the threads can communicate with each other directly. Processes do not communicate with each other directly. Processes needs what? IPC, inter-process communication. Threads do not need the inter-process communication. They can interact directly, right? If you take an example of a web browser, the web browser have one thread to display the images or text, while another thread retrieves data from the network. So one thread may be busy in displaying the image, another may be for text, another may be for retrieving for the data from the network. Word processor may have one thread for displaying the graphics, another for responding the keystroke, another thread for doing spelling checking, you know, the example that I was giving. So in the word processor, it may have one thread for displaying the graphics, another for responding the keystroke, another for spelling checking, maybe some other thread for auto saving. So while you are working with MS Word, multiple threads are working in the background. Web server have several clients concurrently accessing it. You know that in a web server, many clients might be accessing the web server at the same time. Now what it does, if it would create one process for each user, then the client may have to wait for more time to be served. Suppose it will create, for every user it will create one thread. So that will, then the users has to wait, because process creation is time consuming and resource intensive. Process creation is time consuming and resource intensive. So for every user, it cannot create a process, right? And for which what it does, it creates threads instead of processes. Suppose you are accessing the Google, you can think of how many millions of hits will be there for the Google, right? So what it does, it is not creating a process for each of the user, for each of the client. Rather, it goes on creating the threads. As all the processes will do the same task, it is efficient to use one process having multiple threads. All these, they are doing the same task. What it will do, instead of creating multiple processes, it will create one process and may have multiple number of threads. Correct? Your remote procedure call servers are also multi-threaded. All RPC servers are multi-threaded. Remote procedure call servers, where we give a pass some parameter for the server, and we want the work to be done, want to be completed by the server itself. So RPC servers are also multi-threaded. Multiple threads can be created and they can be used for serving the client's request. Operating system kernels are also multi-threaded. Each thread does a specific task, such as managing devices or interrupt handling. So now we can see over here, these threads can also be created by the operating system itself. One thread, what user can create, or we say the user threads. Some threads which are being created and managed by the operating system are called the kernel threads. So we'll be discussing that over here, but before that, let me tell you what are the advantages and disadvantages of these threads. The advantages of the threads is that responsiveness. So the process, if the process is being may have a number of threads, what will happen? The threads will run very quickly, and it's because the message passing, or you don't require a message passing over here. No, these are lightweight processes, so they are very quick. So the response time or responsiveness increases. User will immediately get some information over there. So it may allow continued execution if a part of the process is blocked. Even a part of the process is blocked, the rest of the part will be continuing because another thread might be working over there. Suppose you are accessing from the web, fetching data, it is taking some time. Maybe at the same time, other threads may be busy in fetching the images or text. So if a part of the process is even blocked, it may be busy in accessing the other information. It's performing a length operation, especially important for user interface. So particularly for user interface, it is very much responsive. We'll get some information if you are using the threads. The resource sharing. The threads share resources of process. Do you remember? The threads share resources of a process. They do not have been allotted with resources. So threads share resources of a process, right? So whatever the resources are being allocated to a process, all the threads that are for that process can share it. So easier than shared memory or message passing because they can share the resources. The next one is the economy. It is cheaper than process creation and thread switching. It is cheaper than process creation. How it is cheaper? Because for creating a process, you need many information has to be kept. And for process termination, switching among the processes, all these takes more amount of time, more work, more operations. If you go for context switching, if you find many things has to be saved, then you have to reload. If you are creating a process, many information has to be kept. If you are terminating even, you have to do many tasks. But for thread, it is not like that. Thread, we don't need anything because it is everything, most of the thing it is sharing from the process. What it has only, it has its own program counter, registers, it has its own stack. Correct? So thread switching lower overhead than context switching. The thread switching has lower overhead than context switching because the threads share resources of the process. Correct? So as the threads share the resources of the process, therefore it doesn't require much of the operation to be performed. So therefore these are called the lightweight. They are called the lightweight processes. Correct? Just a second. And what the more next advantages is that utilization of multiprocessor architecture. Suppose I have a multiprocessor architecture. I have multiple number of processors are there in my system, and if I have I'm using a multi-threaded operating system. So my operating system can support multiple threads. What will happen? I can assign the thread. I can say that these threads can be run in multiple number of processors in parallel. So the process can take advantages of multiprocessor architecture. We can run different threads of one process in different processors. So I have multiple number of processors. what I can make these threads to work on different processors at the same time. Just think of if I have a processor of even if a quad core processor or octa core processor, and I want to execute a multi-threaded application, right? So in what will happen, that makes sense that these may be assigned to different threads. I am downloading from files, I am working on some other work. So this may be assigned to different cores and they can work independently. So multiple threads can be assigned to different processors so that they can run parallel. So therefore, we are taking the advantages of multiprocessor architecture. So these are the advantages: responsiveness. So the user will get its response very quickly. Sharing of resources and sharing of resources because the threads share the resources of the process. Economy of economy because thread switching, thread creation, and thread deletion takes very less time as compared to the process. But there are many disadvantages. What are the disadvantages? Writing multi-threaded programs requires very careful design because it's not like that. If you are single-threaded program, what suppose you are one process you are running, that's fine. But if you are going for multi-threaded program, so my operating system has to be designed in that way, right? So multi-threaded programs, if a user is writing a multi-threaded program, wants to use the multi-thread, then it has to write the program in that way. So careful design has to be done. So the program that you write for one process or a single thread may not be suitable for a multi-threaded, right? So debugging a multi-thread program is much harder than debugging a single thread program. If I have a single thread or one process is there, then debugging may be easy. But for multi-threaded program, expecting that where the output is, tracing and correcting errors is quite difficult, right? Because I have the same code is being running on multiple number of, might be running on multiple number of processors. A program that splits a large calculation into two and run the two parts as different threads will not necessarily run more quickly on a single processor machine. See, not necessarily that always dividing the task will take less time as compared to in one machine. If you have a very large task and you are dividing among 10 processor and combining, maybe it may be sometimes faster, but not always it is faster. If I have to sum of 10 numbers and I want to do it by dividing into threads, then that will take more time. The program that splits a large calculation into two and runs in two parts as different threads will not necessarily be run more quickly, not necessarily. So we are expecting that it may be, in many cases it will be run quickly, but not necessarily that every time by dividing it will take less time. Is there any doubt up to this slide? Anybody having any query up to this slide? Okay. Look into this diagram. We have a single threaded process and a multi. Single thread means one process is running, that is one thread you can think of. One process means one thread is over there. So in a single threaded process, what you have code, data, files, registers and stack. The program is running with some codes, some instructions, some data, some files may be opened. Some registers are being modified, content of registers and the stack. These are the content of a single thread or a single process. One process means it must have one thread running over there. It is running with one thread. But in a multi-threaded, there might be multiple threads running, right? But do remember, all these three threads will share this code, data and file. the code, data and file are common for all the threads. The code, data and file, these three are common for all the threads. If I create 10 threads, for all the threads, these three are same. These three are common. So each of the thread can access the code, data and files. However, each of the thread had different registers and stacks. Each of the threads has different registers and stacks. And they do have different program counters also. Each one has different program counter as well. Correct? So we have, for every thread, separate registers and stacks are being created. For each thread, separate registers and stacks are being created, whereas each of the thread shares the common code, data and file of the process. Is it understood? Is it clear? Just see over here. This is the process in which we keep process state, register, stack pointer, many informations we keep for process in a PCB. There is a code segment, data segment, there is a heap, stack, and this is the memory. This is how the memory, in memory a process is being kept. The same process when it has threads, so process now have multiple number of threads. So you can see over here, suppose I have 3 threads. What I have to keep? I have to keep the thread states only. So to keep these thread states, what information I have to keep? I have to keep only register, stack. I have to keep register, stack, the program counter for the same. There is a query over here. Can increasing the default thread stack size decreases the number of threads that can be created? No. See, what I understood from the question is that if I decrease the stack size of the thread, whether that will decrease the number of threads that can be created? No. See, first thing is that, as I said, stacks are different for different threads. So what we have, the process will instruct that how many threads to be created, or user will give a write a program and request for the operating system to create a thread. Now what will happen, for every thread, separate register, stack, some registers, stack for that particular thread, the program counter, these are being created for every thread. But code, data and files are remain same. Well, all other things, memory, everything is remain same. They will be sharing all this. So what is different now? They are updating their own registers. Some registers are assigned to these threads. They will be having some informations are keeping for their in their process stack, thread stack, and there is a program counter which is being iterating or not iterating. It is going over the thread, the instructions which are assigned to a particular thread. So it doesn't have any relation whether the stack size is increased or decreased. Correct? Some memory is being allocated for each of the threads for creating the stack. Is it understood, or any further clarification is required? So okay, so now you look here, the threads contain only necessary information such as stack for local variables, function, argument. For these things it requires a stack, a local variable, function, argument, return values. Then we a copy of register, program counter. So it requires what? Register, stack for different informations and the program counter, right? Now let us go for differentiating between the process and a thread. We'll see that what are the different differences between a process and thread. There are many differences. We'll be quickly going through these differences. First is, what is process? process in the process is program is in the state of execution. An executing instance of a program is called a process. And what is a thread? Thread is a subset of a process, right? Thread is a subset of a process. So we say it is a lightweight process. Actually, we say it is a light LWP, lightweight process. We say it is a LWP. Correct? Why do we say it is a LWP? Because it shares the code, data, files, memory of the process itself. Now, in a process, it has its own copy of data segment of the parent process. Own copy of the data segment of the parent process. But what it said, data segment, it has direct access to a data segment of the process. So thread can have access to the data segment. I have already told data and code can be, data, code and files can be shared. So threads can have direct access. How do the process communicate? Process communicate with each other through IPC, inter-process communication. Is it or not? We have discussed earlier. Processes communicate with each other through inter-process communication by giving send and receive like that. But here in thread, they can communicate directly. They can communicate directly because all the threads belongs to the same process, right? So threads can directly communicate with other threads of its process. What overhead is that processes have considerable overhead, but threads have almost no overhead because threads sharing the resources and memory of the process itself. So no extra overhead over here for communication or for other purpose. So no overhead means it is a very negligible overhead we can think of. Creating a process requires duplication of the parent process. But in thread, the threads are easily created. Threads can easily be created. But in process what? The process requires duplication of the parent process. Whenever a process is created, it's a duplicate of the parent process, then we can assign new program to run in that process itself. But it's a duplicate of the parent. But here no threads are easily created. Sorry, new threads are easily created just by giving the command for creating the new thread. If you think of the control, processes can only exercise control over child processes. So processes has control over its child processes only. In thread, the threads can exercise considerable control over threads of the same process. So inside a process, if I have 5 threads are running, so one thread can have control over the other threads, can exercise considerable control over threads of the same process. Any changes in the parent process doesn't affect child process because these are running independently. Processes are independent to each other. And they do communicate through inter-process, but they are independent. But threads belongs to the same process, so any changes in the main thread may affect the behavior of the other threads of the process. Any change in the main thread may affect the behavior of the other threads of the process. We'll see example in the subsequent slides that how one thread can affect the other threads actually. Correct? So here the threads may affect other threads. Other threads of the same process, do remember, other threads of the same process. Memory is that run in separate memories. Every process has separate memory area. But in thread what? They share the common memory. Already we said the thread as it is a part of the process. So memory is allocated for the process. So no extra space is required for the thread. Thread will share the memory space of the process which is created. File descriptors. Most file descriptors are not shared. Most file descriptors are not shared. File descriptors are details about those file structures. those are not being shared among the processes. But here, the file descriptors are shared among the threads of the same process. If a file is to be used by multiple number of threads, so file descriptor is also shared by all the threads, so that every thread can have access to that file. For the file system, there is no sharing of file system context. In process management, sharing of file is not there, but however in thread they do share the same file. So you can see, if you have remembered this diagram, they are sharing the files, they are sharing the program, means code, they are sharing the data. These three are being common. Even the signals that are being given, right? So that it is saying that the file descriptor memory, file description, and file system, these are being shared in case of thread, and these are being separate in case of process. Similarly, for the signals, it doesn't share signal handling, but here it shares the signal handling. So signal handling for multiple threads, you can have a single signal handling, but for different processes, you may have different signal handling over here. We'll be discussing some more about the signal handling also in the subsequent slide. The processes is controlled by the operating system. Processes are being controlled by the operating system because it creates, it destroys, whatever it is being done by the operating system itself. User usually doesn't interact over here, but the threads are controlled by the programmer in a program. So we will write a program for creating threads, managing threads, deleting threads. All those are being managed by the programmer. But this is being almost controlled by the processes, right? Process is almost controlled by the operating system. So if you look at the dependency, the processes are independent where threads are dependent. Why the threads are dependent? Because they are a part of the process. Is it understood the difference between process and thread? Anybody having any query about this, the difference between process and thread? Could you understand what is a process and what is a thread? Process, for process to remember, for every program, when it is to be going for execution, a process is created for which a PCB is created, and many information about this, all information about the processes are being kept. But if you go for thread, a process may have multiple number of threads that will share the code, data, and files. So the same memory is being shared by all the threads. Threads are dependent with each other, processes are independent, right? And threads are, we said, is a lightweight processes because they do not have a copy of the process, right? So only what is different for a thread, the registers, the stack for the threads, and the program counter, these are different for every thread, but all other things are common and they are being shared by all the threads. Is that clear now? So basically we will have two different kinds of threads over here. We have basically two different kinds of threads, user threads and kernel threads. User threads and kernel threads. What are user threads? The threads provided at user level and management done by the user level threads. Well, suppose it says that if a thread is created and managed by the user, by the programmer, then we say it's a user threads. The program will write code for creating the thread. Managing of the thread is also by the programmer. Then we say these are user threads. Examples of some user threads are P threads, Windows threads, Java threads. These Windows threads also can be system threads or kernel threads can be. So this Windows thread, we can write, the user may write the code for creating the threads, or there might be some threads will be generated and managed by the operating system itself, by the Windows itself. So anyway, so you have some user threads like Java thread, P thread, and Windows threads are the user threads. And what are kernel threads? The threads provided by the kernel level, by the operating system level, are called the kernel threads or system threads. Kernel threads are also called the system threads. These are supported and managed directly by the operating system. Is it understood? So user threads are what? If a thread is created and managed by the programmer, it has a thread library which uses those. Those are called the user threads. And what are kernel threads? If a thread is being created and managed by the operating system itself, then we say those are kernel threads. So virtually all general purpose operating systems like Windows, Solaris, Linux, Unix, Mac, all those operating systems, they do have the operating system or system threads. They do have the system threads or kernel threads. So they have these operating systems. They can have they'll have their multiple. They support the multiple threads, and they do manage those threads. So if it is created and managed by the operating system, therefore we said these are the kernel threads. Is this understood between user thread and kernel thread? Is it understood or not? The user thread and kernel thread. Okay. Going for the multi-threading models. Multi-threading models. If we have one process, then there is no problem because one process might be running with one thread itself, right? If it is a single thread, there is no problem. The resources is allocated for that thread, and you do not have much mechanism for handling the single threaded applications. But in a multi-threading, there are different models will be adopted for implementation of these threads. Multi-threading model talks about the relationship between user threads and kernel threads. So what we are going for, if you go for multi-threading model, we'll implement it. But when we implement this, the programmer will implement this multi-threading, right? So even if you create, when you go for writing commands for multi-threading applications, but these threads has to interact with the system thread, because we have discussed over here user thread and kernel threads. Even if you have some user threads, they have to interact with these kernel threads. So there is a relationship between the user thread and kernel thread. If user thread wants to do some work, it has to be how it is being mapped to the kernel thread so that the task can be completed. So looking into this relationship between user thread and kernel threads, we have three different types of multi-threading models are being proposed. Correct? So there is a relationship between the user threads and kernel threads, right? And looking into this relationship can be modeled into three different categories. So we say there are three different multi-threading models. Multi-threading models are there, correct? So if it will be asked that what is the basis on which this multi-threading model are being designed? Based on the relationship between the user threads and kernel threads, right? So those are one to one, one to many to one, and many to many. One to one, many to one, and many to many. There are three different multi-threading models that are there. So we'll be discussing what are these three different kinds of models are. The first kind of model is many to one. Many to one says that many of the user threads, you can see from this diagram, many of the user threads are mapped into one kernel thread. Many of the user thread are mapped into one kernel thread, single kernel thread. Correct? Many user level threads mapped into a single kernel thread. So the cost is less because we don't have, many times we don't have to create the kernel thread. All many of the user